here, this is what we have got. So we have to write down simply these things. এখানে যা আমরা লিখেছি না, not this. This is what we have got the for r equal to a. যে r equal to a এর জন্য আমরা যেটা পাই সেটা হচ্ছে what is your NFA or DFA, what we will say, and what are the tuples here. So the tuples here, you just write here the tuples. Simply we have got the states Q1, Q2, and the alphabet consists of just one symbol. It's okay. I'm just একটু ছোট করার জন্য. Then this is your alphabet, and this is a delta function. This is the delta function. Also, I make it concise, so I delete this one also. Q1 is your start state. Q1 is your start state. এখানে D equal to হবে না, because you are writing it in native way, so D Q1 upon A, Q2. Also make it concise. I remove this one. So Q1 is the start state, and Q2 is the accept state. And we have got one condition. What is the condition? The condition is, let's hold the bracket actually. We have the bracket actually with the 5 tuples. And with the 5 tuples, so put here in bracket. So now listen, n has 5 tuples are presently and our journey. All the NFA DFA has got 5 tuples. So that's okay. Anyway, we have got here one condition. What is the condition? The condition is that if we have got a symbol B, which is not equal to A, and the state R, which is not equal to Q1, then we go to the reject state. If the state R is not Q1 and the symbol B is not the symbol A, this is not equal to A, then you go to the reject state. This is reject state. Zero stands for reject state. What is shown here? RB is reject state. R is not equal to Q1 and B is not equal to A. This is what is your drawing. Now, not going in your lecture, just follow me. Simply what for R equal to epsilon, the R equal to epsilon when L over R is equal to. So I can copy all these things from here. I can copy all these things from here. So you can power so your 5 tuples also I list it. So the NFA shown here, it consists of the only one state Q. What is this one? এটা আমরা কোথায় লিখেছিলাম যেখানে রাখা হয়েছে। So this is what you have got the Q1. If the one there হয়েছে, you're going to put there also one here, and you have got the this alphabet, but you have got only one string, the null string. Then the delta function. What is the delta function? The delta function is just you go back to itself. You go back to itself. You have the start state Q1, and the except state is also Q1. Except state is also Q1. Right. Where if R is any other state and B is any other symbol except epsilon, we go to the reject state. We go to the reject state. তাহলে এই অংশটা এখানে আছে। এটা প্রয়োজন নেই। কিন্তু আমরা একটু হাতে লিখতে পারতাম, কিন্তু যা এখানে লেখা আছে সব ঠিক আছে। Number three, এখানে ওই ভুলটা হয়েছে, B is not epsilon. B is not epsilon. In this case, we have got the just equal Q1 was the excess state. But here Q1 is not the excess state. You go into Q1, but you can go out. So here, as before, we have got the NFA 5 tuples. The start state or whatever you can say is Q1, and there is no symbol inside, not even epsilon. And then this is what is your delta function. If anything what is there, it takes you to Q1. It takes you to Q1, and your start state is Q1, and excess state is also Q1. The start state is Q1, excess state is also Q1, but Q1 is the 5. We name that the Q1 is Q5. তাহলে এখানে কি আসে? So what we have got here, if R is any state, R may be any state is not equal to Q1, even it may be any state, and B may be any symbol. B may be any symbol. So we go to the reject state. So just write here R may be any state. তাহলে better to take it from here. এখানে দিলে ভালো হবে। This one we take it from here. Copy, and put it here. This is what is your answer at this point. এরপর যা আছে এটা just you have to prove it by the construction, the R1 union R2 etc. You just will go. Define the generalized non-deterministic finite automata. The GNFA are non-deterministic finite automata wherein the transition arrow may have any regular expression at level. So they are non-deterministic finite automata where the transition arrow may have any regular expression as level. Then it subscribes the start state of GNFA has no incoming arrow from any state, and there is a single excess state of GNFA which has no outgoing to any state. The levels on the edges are treated as regular expression for us. So this is the general characteristic. How it is treated to বলা হয়নি না, লেখা হয়নি যে GNFA is created out of the DFA. আচ্ছা, write the formal definition of the GNFA. So it has got the Q is the finite state, sigma is the input alphabet, and we have got the delta function like this: Q minus Q except. Then you have got the partition product Q minus Q star, and this will give you the expression, a level on the transition. Then the symbol R is the correction of all regular expressions over the alphabet. This one, so we have to get rid of these. Not the 5. Also, so Q start with the start state and Q accept with the accept state. So this is what is the formal definition of generalized non-deterministic finite automata, and what is written here is the fine tuple. So, nice steps of conversion of DFA into equivalent regular expression. So we get a DFA, obtain a two GNFA by removing the. So create a generalized non-deterministic finite automata from the deterministic finite automata DFA. But how? Okay, it's written here probably. Add a new state of the DFA that has no incoming. So obtain a two-state on the GNFA by removing the intermediate states and symbols on the edges are united. Read the level of the transition edge of the two states on the GNFA as regular expression R. So how you obtain it? Add a new star state to DFA that has no incoming edge from any state. Connect the new star state to the old star state of DFA through absent transitions. Add a new excess state to the DFA that has no outgoing edge to any state. Connect all the old excess state of DFA to the new except state through absent transitions. Now how you are going to join? The first one is union, so you have got the parallel, and it can be combined to one as A union B. Similarly, you have got 3 consecutive states. You can eliminate the middle one, and the levels are concreted. Then you have got the star. You also remove here the middle one state, and here you have got the loop upon this. So this will be depicted if you put C star between A and B levels. Now, so that's all. Describe the pigeonhole principle for any DFA. So this is what is your verbal definition, that in a walk of a string, the number of the transitions are larger than the state of DFA, then the state is repeated. You have to add here probably what is called the, oh, already added here. And now the mathematical one. If a string W has length larger than P is the number of the states, then a state must be repeated in the walk of the string W. This is the mathematical one. It is mathematical, or we say this verbal. So here the transitions are the pigeon and the states are the pigeonhole. So the pumping lemma. The pumping lemma of regular language inverse. The property states that all strings in regular language can be enlarged, pumped, if there are at least as long as a certain special value called the pumping length. Pumping length. So we should write that pumping length is the number of the states. Pumping length is equal to the number of the states DFA we have written here. Anyway, this means that each such string contains a section that can be repeated any number of times with the resulting string remaining in the language. And this is a mathematical one. What is the mathematical one? If the length of this string P is larger or equal than pumping length, then this string can be broken down into three pieces, X, Y, Z, where the middle one can be increased or pumped. What is the condition? The conditions are number one. In the middle one, Y cannot be equal to epsilon. The length of this middle string must be larger or equal than 1. It cannot be equal to epsilon. And together, the length of the string X and Y should be less or equal than this pumping length. Then, actually, 3 is then for all I is larger or equal than 0, the string xy to the power I have এখানে, you should put here to the power I is also in the language L. I will borrow হাতের হয়ে গেল. Is also in the language L. So this is what is your formal definition of pumping lemma. Lastly, where it is used. Why it is used? I just write here used to pumping lemma used to verify whether a language is regular or not. A language is regular or not. Or not. So this is the usage actually. The pumping lemma is used to verify whether a language is regular or not. Is regular or not, without creating the DFA or anything. তাহলে দেখা যায়, for example, we have got a language like this. For example, A, B, C, and then the other string is A, B, B, C. Then you have got other string A, triple B, C, and so on. You see that this string can be pumped out. We say that this language is, regular. This language is regular. So we say L is regular. L is regular. L is a regular language. On contrary, we have seen that if you have got a language like, for example, A, B, you have got A, A, B, B, you have got A, 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 B, 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 and so on, and so on. This type of language. So using the pumping lemma, we can prove that this language is not regular. So this language is uh, not regular. Just like this. So pumping lemma is used to verify whether a language is regular or not without creating the DFA. Without creating any DFA. Is it clear? Without without creating DFA or NFA, whatever there may be. আমি এখানে just আমি NFA লিখে দিই because NFA is much more representable. N F and A. Without creating the finite automata. Okay. Finite automata. So this is what end of this homework. You just work upon it. Work upon it. The drawings you must take from the this slides. I was working with the drawings on the text editor notepad. That's why I couldn't draw all these things. Notepad coordinate, I cannot put the circles here, the arrow here, for example. So you should have an arrow here. L is regular. This probably is not needed. This line is not needed. This doesn't belong to the. So thank you a lot. Your time has already finished. Don't go. I must take your attendance.
Sir, our exam date is already given.
Your exam date is due. It's probably on 11th.
11. Yes, sir.
It's on 11th. Unfortunately, the timing is not very good. It's a Friday. ফ্রাইডে কোনো একটা পর্যন্ত যদি পরীক্ষা হয় কিন্তু বের হয়ে মুভি পর্যন্ত একটা পার হয়ে যাবে I don't know how these people arrange this type of schedule. আচ্ছা আমি ওই অ্যাটেন্ডেন্সটা সেভ করতে চেয়েছিলাম so this is your attendance export as so thank you. If you have got any question, you can ask me tomorrow. Tomorrow you have got
Okay.
a class